Hi, welcome to the very first episode in our brand new YouTube channel. My name is Craig and I'll be your host on this vlog where I discuss and rate a typical South African craft beer or a craft beer that we might find in the South African market. At the same time, I'll attempt to repair a consumer electronic good that you might find in the average South African home. If you haven't done so already, please pause this video now, take the time, expand on the little arrow below and read the tips and disclaimers. I'm going to set up the bench now and we'll see where we are from there. So here we are on the bench. Let's jump right into it. The beer I'm going to be reviewing today is one of our own. It's an English Pale Ale that I brewed, and I'm going to review it against the Beer Judge Certification Program style guidelines because I think it's only fair. It's a baseline that we can review all the beers against. Unfortunately, with the latest version of the Beer Judge Certification Style Guidelines, the 2015 edition, there is no English Pale Ale. The style that took over for the English Pale Ale is 11B, the best bitter. So this beer fits into all those categories. It's a lowish alcohol. This one weighs in at 4.6%. What is very nice to me about this beer, it's got the aroma is more malt driven. So when I actually smell the beer, I'm getting a honey, almost treacle aroma, which is very nice. The appearance I think fits within the style guidelines. Pale amber to medium copper color. Well, yeah, we fit in there. Mouthfeel, medium light to medium body. Definitely this is on not dry but medium mouthfeel. Commercial example, you can probably get yourself something like a Fuller's London Pride if you can find it in South Africa, and this is probably the closest that I have been able to get to taste with this beer. The recipe, very simple. I'm going to give you the percentiles in fermentation contribution because that makes it easier. Then you can go and work out your own recipe and brew to any size you want. 88.6% Maris Otter, 4.5% Munich 20 Lovey Bond, 4.5% Crystal 120 Lovey Bond, and 2.4% biscuit malt or Vienna malt. What that does is it gives me that honeyish taste, but it gives me that nice baking. Remember, if your parents, your mom were baking, you get that wonderful aroma of cake scones that you almost get that out of this taste. The hop addition, quite easy, 60 minutes, 20 minutes, and 1 minute. The bulk of your bitterness coming from the 60-minute addition. Typically only East Kent Holdings. So that's our beer for today. So today on our bench we have this Mxx Energizer board. It's typically a board found in the South African home where you have electrical fences. What this thing does is it will go and put electric pulses into your electric fence to keep out intruders. Well, that's the thought anyway. The owner bought me this board and asked me to have a look at it. He said it had lightning damage. So as we can see, if we look here on the bottom right, where this little red point is, there's a fuse missing. And if we look up here in the middle top of the board, there's 2 more fuses missing. So that tells me when he had lightning damage, it blew the arse end out of those fuses. So it would tell me that it is also a few more things that voltage would destroy. Electronics doesn't like over voltage. Now, what I want to do is I want to concentrate on here, that fuse holder, those 4 little components there. We're going to call them diodes because that's what they are. Instead of me calling them doodads, let's call them diodes. And I'm going to explain to you what they do. Not how they do them, what we do. We can always get into the how later on. now is important to understand what they do. These three black cans are capacitors. There's a little transformer here, a little switching transformer here, and there's another little black component here. That is a power MOSFET. For now, we're interested in this power circuit because I think we have a problem here. If we've blown that fuse, something around here is gone. This little blue thing, that is a metal oxide varistor. We'll get into what it does now. To make this easy, I'm going to draw a very simple circuit for you. And of course, we can't continue until the senior QC engineer has arrived. Somebody has to make sure I'm still alive when I'm doing this. So let's go back to our circuit. Okay guys, I need to explain a few little simple concepts about the components that we're working with. And the easiest one to understand is really the diode. If you understand the diode, you've got everything. And a diode we normally draw like this, and we prefix it with a D. All a diode does, if I put a positive voltage there, a negative voltage there, and this is more positive with respect to that, and it's normally 0.7 volts or 700 millivolts, then this thing will allow current to flow. If I reverse bias it, like that, and I put a positive voltage here and a negative voltage here, nothing will flow. So that way it will allow current to flow through. That way it does nothing. It blocks it. Simple, nothing to understand. How does this work in an AC circuit? Well, let's draw our bridge rectifier. Those 4 diodes that we had. Sorry, I'm not really good at freehand, and I don't own Dave Cad from EV Blog, but anyway. I know a few things about this circuit. If I put voltage there, and I put voltage there, so we're going to put our AC source here. If this is positive, that cycle, in other words, our AC source is doing that, perfect. That is the positive cycle. Well, if we go back here, the positive cycle, that diode will switch on and allow positive voltage. That diode will block it because that is positive. So we'll have a plus here. If we look at the negative wave of the cycle, well, that diode's going to block it. But haha, that diode will switch it on. So we'll have our negative. Sorry, correction, that is in that part of the cycle. If we look at that part of the cycle, so that is now negative, well, that diode's going to block it, so it won't allow it through. But that diode will pass it. And we'll have our negative here, which would mean that that cycle is positive. So that diode will pass it, we'll have our positive here, but because that's positive, that diode will block it. Simple. So what have we done? We've taken our AC wave and we've created that. Perfect. So now we can see our 4 little diodes there, with our fuse holder and our little AC input. We've forgotten, let's just refresh it. Our AC input through the fuse, through those 4 diodes, and then our MOV, and our 3 capacitors. Now, what you'll notice on each diode, there's a line. There's a marking line, a marking line, a marking line, and a marking line. That line represents what we call the cathode. So in a diode, the cathode is negative, and the anode, the positive side, is the side without the line. So that's the anode, that's the cathode. Now if I switch my diode, or correction, sorry, If I switch my multimeter to diode check mode and I do this, that's a dead short. So we shouldn't have a dead short in both directions. We should never have a dead short, but period. So let's try and get my multimeter in there and there. You hear the diode beep? One way. Great. Let's do it with the same with that one. Ah, fine. Let's reverse the polarities and do it with these. Oh no. We reverse it and we check it again. So this second diode from the left over here has got a short in both directions. That one's fine. Why are these other ones beeping in both ways? Because of this diode that's short. Now, how can we verify this? Let's put a fuse in. Let's see if I've got a working fuse. The QC engineers are now fighting for their spot on the board. So I'm going to put that fuse in there. And what I'm going to do is I'm going to measure across where the AC would come in. Now you can't see it, but I can. I can see the capacitors charging up. But when I reverse my polarity, you hear that? Let's just go back the other way. Capacitors charging up. And I have a beep. Let's see if we can get multimeter in here for you to see what I'm actually saying. I'm measuring here, and when I swap it around, not me shorting it out, I'm seeing the capacitors charge. So that tells me the diode is stuffed. If we go back to the circuit, we can see this very clearly. So what I'm going to do, I'm going to take that diode out and replace it with a substitute that I have, and then we can take the circuit further from there. And to do that, I'm going to use hot air. I don't know if I can do this on camera, not with the height of the tripod I have. Well, I can try. Right, so I'm going to try and remove this component online or under the camera. And I'm going to use hot air to do this because it's a, if you can see it, it's a surface mount device, and it's not a nice through hole thing, so it's not like I can put a solder iron and take it off. So I'm going to use hot air, and this is where we get a bit controversial. Guys, trust me, women are better than this. They have a better feel for it, they're more delicate. It's not like a guy will turn it till it strips and then quarter turn back, and then you A4 away. So what I'm going to use is my hot air station to do this. And this is another thing. I can give you the settings I use, but it's for my feel. It's how I feel the component moving on the board and doing weird things and whatever. Typically I I'm going to give you ballpark figures, but it's not going to help you much. But I use 375 degrees Celsius hot air, and then I use about 75 liters per minute of air, and that works for me. So this might be a bit noisy. We're going to try it. We're going to see if it works. We'll bring it in. So there goes. Yeah, there she is. So what I'm going to do is I'm going to bring it in just over that component that we want, and I'm just going to heat slowly that component. I don't want to heat anything else in the area, just that. There she's going. There. Not too bad. I think that worked. Okay, now we've got the component off, so what I want to do is I want to clean this pad, the two little pads that we took it off from. Now, I typically use 2 soldering tips for this, so I'm going to have to change soldering tips quickly because I use an old Weller WTCP50 and I've used this for years and years and years and years. It suits me. The one I ordered in JVC, I ordered out of the post office about 2 years ago, still hasn't arrived, and that's another rant because, you know, in South Africa our service delivery is up to shit, and depending on who you're dealing with, one of them is on strike. So our post office has got my soldering iron and a whole bunch of other nice kit. Like I say, I ordered 2 years ago and it still hasn't arrived. So to give you an idea of the 2 tips I'm using, I'm going to bring them under the camera. So the one on the left is my, let's put it here, is my fine soldering tip, and the one on the right is a little bit bigger. But because these 2 pads that we want to clean up, see down there and down there, they're quite big, so they will soak up heat. The big thing that I don't want to do when I'm soldering is I don't want to put too much what we call dwell time. Right, we're ready to clean the pad up, and I'm going to switch on my soldering iron. I've changed tips. I'm going to use a few things. So I'm going to use isopropyl alcohol. This is cheap crap that we get in South Africa. Unfortunately, you know, this just makes me the murrin. But in South Africa, if we want stuff, then we have to import it, and it becomes very, very expensive. So yeah, for this I'm going to use a cheap Flux that I got from RS Components. Just contact IPA, isopropyl alcohol, and I'm going to use a solder braid. And all I do while my soldering iron is heating up, I spray a bit of Flux there. And when mine heats up, all I'm going to do is I'm going to put the braid that we saw over the pad and just let the braid suck it up. It's important that we start with a clean pad because normally these things are done with lead-free solder, and I am not going to solder with lead-free solder. So all I'm going to do, let's try and get it in here, is I'm going to put my pad over it, and I'm going to put my iron over it. Difficult to do under the camera. There we go. Nice and clean. We're going to do exactly the same to the other pad. If we can get it there. I must say it's difficult working under this camera. Just put a little bit more Flux in. And again, dwell time is very important here. We don't want to keep our iron on there all day and every day, because it will lift this pad. Now all I'm doing, delicately touching it to the braid, that's it. No, that one's not quite clean. Let's put more flux and we try and get a better angle for this. I didn't realize how difficult it is to shoot under the camera. Oh well. There we go. Cleaned. I'm going to switch that iron off because I'm going to go to a thinner. Actually, before I switch it off, I just want to tin it. Very important. Always put a bit of flux on your soldering iron tip when you're done with it. It protects it, it prevents corrosion, pitting, all sorts of horrible things that make you replace pads. So I'm going to clean this up. I'm going to just use a little bit of isopropyl alcohol. And a typical non-static brush just to get rid of all the flux residue. You see, we don't want any of that. It's nice and clean. And I've just realized I fucked up completely. I used a IPA instead of Flux. Oh, whatever. Works. Okay. So now to put the new part in, well, we've got a few options. It really depends on you and your feel for this. One way to do this is to put a little bit of flux on one of these pads, a little bit of solder, and tack the component to it. Now, again, it's going to depend on your feel for things. So I'm going to do it a little bit different. I prefer to put flux down, tin my soldering iron, and then touch it against the component, and that's what we're going to see. What we're going to see us do now. Okay, I'm going to put flux on. And be liberal with the flux. You can never have too much of it. I'm just cleaning my tip because I don't want. Unfortunately, I'm balancing this board on this, so you get a bit of solder out of my balancing, and put it back. So we're going to just put our component back. And there it's placed nicely. I'm going to put a bit of flux on my tip. Hold our component down, and that's it. That's all I want to do. We'll fix it up and make it look neat now, but it's in place. Put a bit more flux on the other side. Unfortunately, you can't really see on the other side, but that's bad. We put a bit more flux in our tip. So let's fix this up and make it look nice. And that looks okay. And we'll do the other side. And that looks good. Yep, that looks okay. Clean our iron off. And we'll just put a little bit of flux on. Perfect. So if we put our fuse back and we measure, our fuse is perfect. We're going to just put it in. Now let's try this again. Ha! No short. No short. And let's measure those diodes because, well, we're here. Perfect. It conducts. It conducts. This is a bit of a bastard to get in. Let's see. Perfect, that one. If I put polarity the way, there we go. So our full wave bridge rectifier is sorted. So now I'm going to go put isopropyl alcohol on again and clean it. And then we'll look further what's wrong with this board because you can't see it, but I can. And then we're going to zoom in a little bit and have a look at that. Okay. See you in the next shot. Right, so I've been through this board after we replaced our little diode down here, and I've cleaned it up. And I found a few more anomalies. So if we zoom in a little bit, I don't know if you can see. I'm going to keep moving the camera. That little transistor over there. Half of it is gone. You see what they look like there? Well, that one's had its arse end blown out. Fair enough, we can replace that. But also what's missing on this board is further up. Let me try and get that into the camera shot. Now I'm digging around with the light contrast. But what we're really trying to see is up here. There's a transistor missing there. Now the owner did explain to me that he'd tried to take out, there we can just see it up here in the top left hand corner. So what the owner did explain to me is that he had a second board that he tried to fix this board with, or fix that board with, and swap parts. So what I'm going to do is I'm going to, off camera, I'm just going to repair quickly. Well, I don't know, maybe we'll do it on camera, we'll see. I'm just going to clean up those pads quickly and remove that other component that we have down here. And let's see what we get then. And now, this transistor that's sitting over here, hopefully we can give you a better idea. So that's the third component that we found that is blowing the arson out of. So I'm just going to remove it with a bit of hot air. And what we can see, quite interesting enough, is if we look just over there, we can see that that pad is gone. So that's going to take a bit of repair, but what I'm going to do is I'm just going to take that component out, clean it up off air, and we'll come back to our board. Now that way you can see I've taken that little transistor out, and what I'm going to do now is I'm going to just clean that area up, and then we'll replace those two transistors. I don't think I need to do it off air, and I think then we're ready to test this board. Right, so my iron is heated up. I'm just going to put a little bit of flux on. Again, same principle. Braid, flux, and heat. And there it's gone. Always tin your tip after you worked. Big secret, clean it before, tin it afterwards. Okay, so those pads look good. Now let's come to the one upstairs. Now, of course, these little SO23 packages, that's the size, are very difficult to replace. So I'm going to try and do this on camera. I'm just putting a little bit of flux down. I'm going to use the same trick I did earlier on. Putting flux, solder on my tip, and I'm just going to hold it down. So it's in place and we're happy. Now, I'm not worried about building solder bridges here because we're going to fix that up. I just want it in the right place. And this RS flux is completely toss. That's our little component in place. Not the neatest job, we'll clean it up afterwards, of course, but it is going to give me contact, and that's all I care about at the moment. Okay, we'll clean it up with a little bit of braid and whatever, and we'll come back to it. And of course I'm going to do the same to the other one, except we're going to have to repair the missing pad, which is a tedious job, but we can do that offline and we'll come back to it. Okay, so I've replaced this little transistor up here, and what you notice is I've created a solder bridge because there's a little pad there that I know that little leg of that transistor goes to. And because the pad of this one was blown out, well, we've created the circuit again. And if we come down, this little transistor down here we've replaced. So that pretty much takes care of everything for this circuit, except we have to power it on and to check it and see that it works. Now, to do that, we have to do a little bit of a thing here, because if we come back to our circuit here and we look at these little diodes, these diodes are not rated for mains voltage. So that tells me that whatever's coming in here is not mains voltage. The same with these capacitors. They are not rated for mains voltage, so they cannot handle 220 volt or 230 volt AC mains. That means whatever's coming in here is a much lower voltage. So I think to keep this video short and keep it on point, what we should do is our next episode we'll build a power circuit that I think can actually switch this on, and we can troubleshoot it further. And so we've reached the end of this episode. If you found what I'm teaching you useful, or what I'm talking about, great, please give us a thumbs up and down below. If you'd like to see further videos, please hit the subscribe. We'd really appreciate it. Now, it wouldn't be fair if I didn't rate the beer, so of course I'm going to do that. The style guide says 11B base bitter. Now, you can download the BJCP style guidelines for free, and it's a great tool for you to make up your own mind about a beer you're drinking. Does it fit the style guideline? Is it not? So I'm going to rate the beer as following. For me, does it fit the style? The style guideline says low to moderate malt aroma. I'm definitely getting that. I definitely get that honey, bread, baking aroma from the malt. The hops don't overpower it. It's actually a very nice beer. It's not especially bitter. It's not a carry away that your mouth becomes like a pupil from a chicken. So I think definitely it fits that. Appearance, definitely it goes there. I don't particularly see it as a off-white head. To me, it's more white. That's fine. Flavor, medium to moderately high bitterness. No, I actually get a very medium bitterness, and that might just be my palate. Great. I don't get anything like diacetyl. I don't get any of those butter notes, those buttered popcorn notes. So, very great beer. Mouthfeel, medium light to medium body. Low carbonation, yes, well, I did carbonate it quite low. And I actually do think it's a medium light mouthfeel. It's not, the lower you go with the final gravity, the drier the beer becomes. So no, it's definitely got mouthfeel. Style comparison, blah blah blah. I definitely think, for me, of the commercial examples I've tasted, I think the Fuller's is definitely the one you want to go for. The Fuller's London Pride. If you can get it in South Africa, I know you can probably go to some liquor cities. They have it, or you'd have to go to Macro. Quite good. So as far as the style goes, I'm going to give the beer 4 out of 5. I think, for me, personally, I could have carbonated it a bit more. I think from the color, I could have made it a little bit more pale. The flavors are there, the aromas are there. The aroma from the hops, very, very, very subtle, spicy, minty, earthy sort of aroma from the hop. For my drinkability, now this is a complete, the drinkability is how many of these things are, would I drink it again, or could I sit and drink it as a session? I'm going to give it a 3.5 there. Pale ale is one of my favorite styles. I really like an English pale ale. To me, this beer is missing something. I'm not sure what, but to me, I definitely feel something's missing. Anyway, I hope you enjoyed this video. I hope you enjoyed this episode, and if you learned something, please give us a thumbs up. If you didn't, give us a thumbs down. I'm not here to baffle you with all engineering, maths and everything like that. That's easy to do. If you'd like to see more of this, more of these type of videos, please subscribe. Catch you next time.